This is the tutorials of Siemens S7-1200, and in this lesson we are going to learn about bit logic operations. And in bit logic operations we will understand NO, NC and OUT commands of Siemens S7-1200, and then we will have some exercise example. So let's proceed with this lesson. Okay, so first is bit logic instructions in letter NO, and NO stands for normally open contact. Okay, now if you know about industrial controls, we also have NO switch. Okay, so NO switch is generally different from NO contact. If you know about NO switch, we have a symbol which is like this, and it is like this. So this is the physical switch which we connect to the PLC input. Okay, so don't be mistaken, this switch is a physical switch, but this is the contact which is inside the ladder logic, inside the programming. So there's a difference between these two. This is the switch, physical switch, which you press manually, and this is the contact which is inside the PLC. So it says the normally contact is closed, it's on, just like you press it, this goes through. So this goes on when the assigned bit, the value I0.0, now this is the address. This address you will find here. So this goes true. By true means it closes when this I0.0 is true or equal to 1. Okay, so when this address is true or equal to 1, this bit will be true. And if this bit is open or off when the address I0.0 is false or equal to 0. Now this address is either true or false. That thing depends upon the switch which is connected to this input or the signal which is connected to this input. Okay, so let me show you one example. Like if you see our camera, now this is my first input, okay, I0.0. okay, if this is true and this goes true by connecting a switch which is connected to its input. Okay, so let me show you. You might remember I have shown you this in the diagram, but I'm just repeating this for your, just so that you can have this thing in your mind. So we have, let me adjust my camera. We have this simulator. This is called PLC Simulator. Okay, a moment. Yeah. Now if you see this, this is the first switch, physical switch. This is a toggle switch. If I make it on, this will be true. Okay, so if I turn it on, this first input is true. So inside the processor there's a contact, we call it NO contact. When this NO contact is tagged with the address of this input, that contact goes true. Okay, so this is my switch and inside it's a contact, so don't get confused. So this is just, I want to clarify that we have switches and contacts separately and their functions are different. Okay, so let me just put it back to focus my inputs and outputs. Yeah, perfect. So okay, so let's move back to our presentation to see some examples. Okay, now in Siemens TIA, in the Siemens software, you will find this contact over here. So if you open the software and if you want a NO contact, it's available here. This is the NO contact. So when you click here and select this one, this contact comes here. This is the one way to get this contact. The another way is you have this basic instruction palette here, and you go to bit logic operations and you take this NO contact from here, normally open contact, and you can drag it like this. Okay, this is the another way to have a contact. So this was the NO contact in Siemens PLC. Now let's see some example. We can connect a contact in series. So you have two contacts, tag 1, tag 2, with the address I0.0 and 0.1. You can connect that in series. And if you connect that in series, the output, by output I mean if you connect anything here, the output here, this will be false if both the contacts are 0, 0. It means both contacts are false. This will be false. There will be no output here. The output is false again if only one of the contact is true, which is I0.1. So if I make it true by pressing the switch on the output, again this will not be on because the signal will not flow. There is no signal here. So if the first input is true, if this is true and this is false, again this will not be on, because this is an AND gate. If you know an AND gate, in AND gate, if both the inputs are true, then only you will have a signal from here which will pass from here and it will go to the output. So this is what it means, a series example in series. This is made by two NO contact in series. So another example is parallel connections. You can also connect that in parallel. Just we have seen in the last lesson of branches, we have connected two NO contacts in parallel, and if you see their logic, if both are false, there will be no output. Here there will be no output if both are false, because there is no signal coming from any of these contacts. If one of the input is true, so if either this is true, then the signal will come from here and output will be on, or if this is true, again signal can come from here and go to here, or if both are true, then only output will be on. So this is a parallel logic you can make using two NO contacts in parallel. So this is a very simple basic lessons to understand series and parallel contacts using normally open contact. Okay, so I hope this makes sense, and we will do an exercise to understand and work practically on the PLC. So let's proceed with the next slide, which is the same instruction but in FBD. FBD is a functional block diagram, another programming language of PLC which is widely used in Siemens most of the time. So this is the block symbol of a normally open contact in FBD. Okay, this is also, you can find that in Siemens TIA, it's over here. Now you might be wondering how to move from ladder to FBD. So to move from ladder to FBD, it's very simple. Suppose I take this contact and I put I0.0. So this is my contact. I'm not using output. So if I want to see this in FBD, I don't have to design it again. It is a function of the software. You can right click on your main block, go to switch programming language and switch to FBD. So you have this block here. So I haven't connected anything on the output yet. So you have this input automatically linked to a block, which is NO block, and this is the input tagged as start. If I want to go back to ladder, just right click here and go to ladder. Okay, I hope this makes sense. So we are understanding FBD, so I move to FBD. So this is the FBD logic. You can see like this by right click on the main block and I move here. So the same example of series and parallel, you have two contacts in series, I0.0, 0.1. This is the series, and if you notice this symbol, and this is the symbol of series, because if you know, the AND gate is symbolized by the symbol, and the truth table is same as what we have understand before. So if you see the same thing in parallel, you have the symbol like this, greater than or equivalent to. Okay, so these are the two inputs which are connected in parallel. So if you see, if you don't consider this symbol, the block look almost similar, but the symbol makes sense. If there is a symbol like this, this is an OR logic. If the symbol is like this is the AND logic. And the truth table is same. If any of the input is on, any of this is on, or if both the inputs are on, the output is true, otherwise it's false. In this case, if both the inputs are true, in this case, in the last one, the output is true. So this is the AND gate, AND logic, or OR logic. I hope this is clear. Okay, so now we have normally closed contact. Okay, now normally closed contact, this is the opposite of normally open. That's the shortcut to understand if you are learning PLC for the first time. Normally closed contact is the opposite of normally open contact. Okay, so as I explained you in the last slide, that if you have signal 1 to the input, okay, let me take the red color. Now if this is tagged as I0.0, if you have on the first input the signal 0, then this will pass the signal. Okay, this contact is closed when this is 0. This is what it says, this contact is closed when the assigned bit value I0.0 is false or I0.0 is 0. So this contact is closed or equal to 0, and it's open, it's off. So this contact will look like this. This is open in the case if the signal coming to here is 1. Okay, so this is exact the opposite operation of your normally open contact. That's why you have the symbol. This is the invert logic. So this is called normally closed. Okay, the rest we'll see that in the in the live demonstration. Okay, so now the examples, we have a NOR logic and we have a NAND logic. So two NC contact in series makes a NOR logic, two NC contact in parallel make the NAND logic. Now what is NOR and NAND? NOR is basically OR plus NOT. Okay, so if I take some pen here, now if you see here, it says if both the inputs are 0. I told you if this is 0, this contact is closed. So if this is closed, it will pass the value. If this is 0, this is also 0, this is also pass the value. So the output will be true in this case. Now next case is if first is 0, second is 1. Now if this is 1, this will be open. Okay, this will be open. So it will not pass the value. So output will be false. The value of first input will be just stuck here. It will wait for this contact to close to pass the value. So output will be off. Or it says if the first contact is true, 1, second contact is 0. So if first is 1, so this will be open. So if this is open, as I told you, signal flow from left to right, even this is closed, output will be off because signal will not pass from here. This is the third case. Last case says if both are open. So if this is open and this is also open, so in the last case it will be like this. If both are open, output will not be on. Okay, this is very easy to understand. So the output will only be on if both the inputs are closed. Okay, this is the NOR logic used by two NC contact in series. So what will happen if you can connect these two in parallel? This will become a NAND logic. NAND is AND plus NOT. AND plus NOT. OR plus NOT is NOR. AND plus NOT is NAND. Now what does this NAND means? It says if both the inputs are true, output is true. Of course it will be, because if this is 0, it means this will pass the signal. If this passes the signal, output will be on. Also if this is 0, output will also be on. So if both are 0, output will be true. If first is 0, second is 1. So if this is 0, of course this will pass the signal. This is parallel. This will make the output on. If this is true, this will be open, but this will not affect the output because this is only passing the signal. So if any of these two pass the signal, output will be on. That's why if any of the input is true and another is false, output will be true. If both are false, output will be true because this is NC. But if both are open, now if both are open, this will be like this and this will be like this. So if both are 1, nobody can pass the signal. This will not pass the signal, this will not pass the signal, and output will be false. This is a very simple representation for a NAND logic using two NC contact in parallel. So you can practice that in your logic. If you have a PLC simulator, you can use any simulator because these are the basic fundamentals which you can practice in any PLC simulators. Okay, so let's proceed to next slide. The similar case we'll see in FBD. Now if you notice here in FBD, this is the block, and I will just open all of the elements. And if you see here, this is similar to AND logic, but you have this small circle here. Okay, this circle represents NOT, or you can say that it's inverse. Okay, so this is the signal and this is the NOT. So if you just consider this tag combination with this symbol, this means an NC. Okay, if you don't find the signal, then it means it's an NO. Just we have seen in the last logic. So if you find the signal, this is a very small circle. You have to notice that this means it's an NC contact. Okay, it's an NC contact. So this is the output. Now here, this is NOR logic again, two NC contact in series. Now why it's in series? Because it's an AND logic. We have AND here. So this NC contact in series with this NC contact. Okay, so this is the same NOR logic you will find in FBD. Similar in parallel, you have this NC contact in parallel with this NC contact, and you have this output. I hope this makes sense. You just have to focus on whether you have this bubble or small circle in your FBD or not. If it is there, it means it's an NC contact. Okay, so let's proceed next and see some examples. Okay, before coming to examples, we have to understand an out coil because this will complete our ladder logic. So we have this out coil in ladder logic symbolized by this symbol. You have these two lines here which symbolizes an out contact, and in FBD you have equivalent sign. Equivalent sign means whatever logic you have on the left will be given to the right. Okay, so this is mentioned here in the software. And to see an example, we have this example of ladder logic with series connections. You understand the series in the before slides. So this is the output coil. So this output will be on. This is true if both the inputs are high. Both the inputs are 1. So if you see the FBD, we have connected the output block like this to my series input block. There is no bubble here. So this is NO contact. So this is this NO contact, and this is this NO contact, and this output is this output. Okay, so this is the conversion of ladder to FBD. Now it's up to you which language programming you find it easy. You can practice that in your software. Otherwise, you can learn both, because both are very important if you are considering yourself as a PLC programmer. If you are going forward for this profession, you should learn these two basic languages. Okay, so this was about out commands in FBD and ladder logic. Okay.